Uh, Hello, all. Welcome back to the second part of the introductory module, the artificial intelligence in chemistry. So, before we get started with the continuation of that, let us just take a quick recall of what are all the topics that we have seen in the previous module or in the previous session. So, we looked at what is AI for chemistry, why AI is needed for chemistry. We looked at various use cases like how drugs were discovered very quickly as compared to the traditional methodology. We also looked at how AI can help in doing faster discovery. It can help in analyzing the large amounts of data. And we also looked at what are all the various activities that we can do. Like, for example, we said we can look at data analytics, data visualization. Then we looked at exploratory data analysis. Then we said we will look at machine learning. And then we will look at um, artificial intelligence, that is deep learning. Now, in this session, what we will be looking at is we'll be looking more at what is the data or what is the type of data that are there and how do we deal with that data. This session will also have a bit of Python introduction, although it is being covered in another session. We'll also be re-emphasizing the topics of basics of Python with a lot of other examples so that you start getting into understanding the basics much better, and also you will be able to solve some of the exercises as we go on. So, to get started, we will start with what is data analytics. Now, you imagine you have a large amounts of data. For example, let's say you have collected the readings of a large chemical reaction happening over several years, and you want to understand how the reactions are I mean, assume that you are conducting the temperature, your experiment at a room temperature in a normal setup. You don't have a controlled environment, you are just doing in a normal room, and you want to understand how these reactions are changing with seasons, right? Then what you will do is you will collect the data over the years, and then you will map these results with the seasonal data to see how the reactions are happening in different seasons. Like, for example, you want to find out how the touch phone of your touch sensitivity of your phone changes with different moisture levels or different humidity levels or with different temperatures. So basically, we want to understand what is causing a trend in the data. Now you will know, now when you plot the data, let's say you have your chemical reactions and the temperature that it generates or the heat it produces. Now you know that the heat is increasing, but you also want to know why the heat is increasing. So you might need a lot of other data also to basically understand why the reaction is happening this way. So data analytics mainly helps in uncovering hidden details inside the data. This could be several things. For example, if you take up a normal general example, let's say you have 60 students in a class, and then you have their marks that they have scored over the year, and then you want to find out who scored highest, who scored lowest, and people who scored lowest, what is their problem, right? It could be they could have some other understanding problem, or they might have certain personal problems. So what we are trying to do is, you have the data is telling you something. It is telling you that okay, the marks are increasing or the marks are decreasing, but you also want to know why the marks are increasing. Now, when we try to put the same thing in the context of chemistry, we all know that the rate of reaction increases as temperature increases. One of the common phenomena, it is explained by this concept of Arrhenius equation. Now, in this, what happens is when the temperature increases, the molecule starts to collide with each other at much faster rate, and this basically increases the rate of reaction. This is also because of the kinetic theory matter, and Also, there is a effective collision happening when the temperature increases. And you also know, the on the screen you could see the Arrhenius equation, where the rate of reaction K increases based on the other parameters, especially with respect to the absolute temperature in Kelvin. Now, what we can do is, now on your screen, if you see, I have plotted a graph, okay, which tells on your x-axis you have the temperature in Kelvin, and on the y-axis you see the rate of reaction. Now, this plot typically shows how the rate of reaction increases when the temperature increases. Now, how is this actually done? Okay, so for this we would go into doing the data analytics with Python, and we will be covering that aspect of that in today's session, or in this session. Now, to just to give you an idea of how this happens, for example, on my screen you see an Excel sheet. What does this Excel sheet tell you? This Excel sheet gives you the temperature in Kelvin, and the rate of reaction is given in the B column. Yeah, you could basically plot this in Excel itself, but assume that you have a very large data. Okay, assume that you have a very large data and you want to do further analysis also. So, one of the best ways to do this is by using Python code. Now, for example, on your screen, I am showing you the Colab notebook, the Google Colab notebook. We will discuss about this in some time now. But to begin with, what I have is, I have loaded this data into my Google Drive. On my screen, if you see, I have loaded this data on my in my Google Drive, and I am saying some condition here. Read CSV. I am asking Python to read the CSV file. So here you would have noticed some words like pandas. If you are very new to Python, you would not know that, but we will cover that as we go on. Here I just want to give you a heads up of how this happens. So now I go to this sheet. So what I am going to do is, so this is a Google Colab notebook which I have on my screen, and I am now currently clearing all my existing output. Now you can see that I am trying to load this data file. This is a CSV file that I have. I can either have it in my personal computer, or I can have it in some other GitHub repository. Or GitHub repository is a repository where software engineers store their code, data, or all necessary things for developing a software. It could be used for many things. You could also store your documents. You could store even your assignments. All these things you could use it. Basically, it helps you to version control your document. When I say version control, suppose you have a document and today you wrote something and you typed something, and after few days you change that, right? So when you use a GitHub repository, like you use a version control software like GitHub, what happens is, when you upload the new document, it will keep the copy of the earlier one as version 1 and the current one as version 2, and it will help you to compare and do stuff like that. So you could have it in your GitHub repository, or there is also another thing called GitLab. All these are version controlling softwares. Or you could have it in your Google Drive. It is up to you where you want to store the data, depending upon the nature of data. Suppose if it is a very sensitive data, then you don't want to put it in Google Drive. You want to keep it somewhere safe. So I have loaded this data. Now what I am doing is, now in this place, okay, I'll be explaining you in depth of how we write the code, how we debug this code, and how we enhance this code. I'll be telling you. So to begin with, I am just starting with a simple thing where I am loading the data. Now you see that the data is loaded. How do I know the data is loaded? One is here, it says it has put a tick mark, which means that this code has executed without any error. Then I say df.head. So all the data that it has read is stored in this variable called df. df is nothing but, in data science it is called as a data frame. Data science is called as a data frame. So now I am saying printf df dot head. I am saying df dot head, it means just don't show the entire data, show me the only head. Head means it will show the first 5 rows. By default it will just show the first 5 rows, and I say run. So you can see that whatever data was there in Excel sheet, you could see it here. Now in the next line, I know this might look very tricky now. Just to understand what is happening, I am going to run this. What it does is, it creates me a plot. Now when I have this plot, now okay, now I understand. There is a, it's almost like a linear trend as the temperature. I think it should be exponential, but in this case it is not exponential because it's an arbitrary data. It is not the original data. It is just an arbitrary data. So you are just getting the a slightly linear reaction. But if it was actual data, you would have seen a exponential data. So the point I am trying to explain here is, I am not trying to explain you the Python code here. We will come to that in slightly some time from now. What I am trying to say is, you have the data with you. Using Python code, we can basically try to understand how the data, what is the pattern of the data very easily. Now it doesn't stop here. From here I can also predict the future. Okay, now at 360 Kelvin I am seeing this is the temperature. At 400 Kelvin what will be the reaction rate? At 500 Kelvin what will be the reaction rate? I can do the prediction. That is where the prediction comes into picture, or the machine learning comes into picture. Again, if there are more conditions, there are more complexity in predicting, then we go in for deep learning. But a machine learning or a simple statistical technique called forecasting can help us do that. But anyways, now this is not a time series. It is not a time series. It is basically based on increase in temperature. So by now you would have got a simple idea that if you have the data, how you can create a visualization. So that's basically what data analytics is all about. So you will have, again, now this data right now is in a tabular format, but it need not be in tabular format all the time. Okay. So what we have seen is that we are able to use the data that we have and create a plot. Okay, very simply. I mean, it did not actually, if you had seen the code, it was all about 5 to 10 lines of code, and we are able to generate it. And you have to understand here, now here the data that you saw was a tabular data, that is, it has rows and columns. It's a very simple type of data to deal with. But then there are different formats of data which are much complex. Like for example, I want to know, I want to analyze the data of a video, or I want to analyze the data of a voice. Okay, based on the voice, I want to see if the person is happy or not, or if the person is excited, right? Or maybe just by reading the facial expressions, I want to see if he is happy. Okay. Or maybe if I can have a system where people are listening to this, session, are they actually understanding or not? Based on facial reaction, will I be able to do that? So then the data formats are different. There is an image data that is going to come. There is a video data. There are different formats of data which we should always think in mind. But as long as the data is in a tabular format, it is much easier to deal with. Now, why do we need such data analytics for chemistry? As I previously explained, the data, as people say, is the new oil, right? So it's also the new reagent in chemistry. It helps you to analyze your lab results much quickly. Not just analyze, it will also help you to present the data much easily. Suppose you had your lab readings, and you want to present it to somebody with some nice explanation. Now doing that with Excel might not be a very good option, because it might not be interactive. So I want to, now let's say I have created a plot which is for the for let's say 1 years of data. In Excel, if you plot that 1 years of data, it will look very small. I mean, it will be very congested. highly cluttered, you will not be able to make much out of it. But the same thing, if I put it in a Python code and create a time slicer, so what will happen is I'll have a time slicer on top of it, and as I drag the time, it will automatically expand. The data will expand. So I can see it, the chart at 1 year level, chart at 1 month level, 1 week level, and 1 day level, all up to 1 second level. So it helps me in not just analyzing the data, but also presenting to the data to someone so that they also understand and make sense out of it. Again, when you have high volumes of data, now Excel, maximum there are 1 million lines, okay, and that too, if your computer is good enough, say you have a computer which is, let's say, 8 GB RAM, that's even then, if you have 1 million records in Excel, opening that itself is a big challenge. But when you have the data in a CSV format, CSV stands for comma separated values. Now, most of the data that is used in data analytics comes in a CSV format. So, what is a CSV format? Now, in your screen, you are seeing this as two different columns. But if you look at the actual file, right, I'll just open the actual file here. So, this is the file. Now, when I open, see, when I open in Excel, it shows in multiple columns. But when I actually open it here, you are seeing that the rows and columns are separated by comma. Sorry, the columns are separated by comma. You can view that. So, this is called as a comma separated values. That means after each column, there is no line, but basically there is a column. So, if you look at much of the data that is used in data science or data analytics, we expect the data in formats like CSV, because the CSV file format, we don't have a limit. It can have any number of rows. As long as the computer is capable of opening that file, you can still open it. If you are not finding it possible to open with a computer, you can basically put it on a cloud machine where you have a larger RAM, you'll still be able to open it. Okay. So, CSV comma separated values is like a universal way of exchanging data, okay, especially in the field of data science. So, coming back to the, so when you have a very large amounts of data and you want to when you have a large amount of data and you want to analyze those data, you want to do run some simulations, you want to spot some trends. Is it increasing, decreasing? If it is increasing, where is it increasing? Okay, and predict its behavior over the time, how it will change. All these things you can basically do with the help of data analytics tools or programming languages like Python. So, always remember, when we are doing data analytics or machine learning, it need not be always a programming language that will do. Sometimes there are tools available where you can just upload this file and start doing analysis. So, in this course, maybe when we go on to the next module, we will be introducing you to some of the tools which can use these files, and without even writing any code, you will be able to do some analysis on the data. So, this basically stresses the point that because fields like chemistry produces a lot of data, there are going to be a lot of experimentations, there are going to be a lot of simulations, optimizations, and various predictions that are needed. Data analytics becomes very, very key. See, one of the important things of data analytics is it will also tell you whether the data you have is of a good quality to do some predictions. So, now it is not actually possible, or it is not always possible, to have some data and predict the future. If your data itself is not up to the mark, I mean, if the data doesn't have the right amount of information, or if the data is not properly distributed, okay, then just by having data, prediction might not be possible. So, data analytics also tells you whether the data that you have is good enough for doing predictions, whether it is good enough for doing further data analysis, or is it actually fit enough to do a large scale AI system? That is also another advantage of data analytics. Now, that we have understood that data is the key, okay, data is very, very important. Now, let us also see what are all the various data formats. I mean, I would say these are not just data types, this is the formats of data. Now, what are all various formats of data? One commonly available data is called the structured data. What is a structured data? A structured data is like where the data is organized as rows and columns. Okay. So, for example, if I just go to this my screen, so I am opening see, I have a data here now. Now, here you can see that the data is nicely arranged in rows and columns. Okay. You have some columns have a header, right? All the columns have some header, right? Data is nicely organized. This is basically called as a structured data. So, a structured data is an example where you have the data available in some rows and column format. Okay. So, here the data is available in row and column format. So, whenever you have data in such a format, we usually call that as a structured data. What could be the examples of it? For example, your lab experiment results. Suppose you are doing a lab experiment, right? First reading, second reading, third reading, fourth reading. So, each reading you noted the temperature, you noted the time, and you noted the the heat produced, whatever, right? And then you put them as a tabular column. So, whenever you have the data created in a tabular column, basically a structured data or inventory or chemical compound database. So, if you have created an inventory of what are all the chemicals available in my lab, how much amount of quantity is there, right? What is the expiry date of each chemical, right? So, all these things if I maintain in an Excel sheet, it becomes a structured data. That is the first type. So, on your screen, you can see an example of the data analytics type, that is, which is a tabular data, which is the salt concentration and light transparency. So, at various levels, based on the concentration of salt, how does the transmittance, the light transmittance changes? So, there is a graph available. Now that we have a graph, we can plot that. Now that the data is available in a tabular format, we could do many things, including creating a table, predicting, finding the differences, spotting out if there are any outlier values. All these things would be possible from now on. So, that is the first type of data, which we call it as the structured data. Then you have unstructured data. Now, unstructured data, the word itself tells you that the data does not have any fixed format. For example, an image. Okay, an image is a unstructured data, or let us say a video, okay, a video file. I give you a video file in MP3, unstructured data. A Word document is an unstructured data. A PDF document is an unstructured data, right? So, these are the type of data which is very difficult to analyze without doing some pre-processing. What do you mean by pre-processing? Now, for a computer, everything is bits or bytes, 0 and 1s only. Okay. So, the computer will not be able to process anything unless until it is some form of number, or the number at the end eventually will get converted into zeros and ones. Even the text. So, for each text, we have something called as an ASCII value. For example, the ASCII value of A is 65. So, whenever you type A, the computer converts that into an ASCII value 65, which is then converted into a zeros and ones for the computer to process. So, similarly, when you upload an image file or a text file, it will not be able to do anything unless until we do some pre-processing. This pre-processing involves several steps, like converting the format of the file, or converting the color scale of the image, and then converting them into a matrix of the image size, where each number in the matrix represents the color pixel intensity. So it is basically, there is a pre-processing step involved. So examples of unstructured data is basically your research papers, your lab notes, your PDF reports, or the images from the microscope or spectroscopic data files. So when these data come, they all are in some sort of unstructured data, and with the kind of AI tools that are available, we will be able to process such data as well. But then there is some pre-processing required when we are dealing with such type of data. So this is an example on your screen, is a unstructured data. Like these are all some images of chemical compounds captured from a microscope, where the temperature is greater than 90 degrees centigrade. So what we are doing is, from the image, right? So on the first row you see the image. The second row you see a more detailed image of that, which is constructed from the previous image. So for this, what they would have done, they would have done some pre-processing to remove the background, remove the noise, improve the sharpness, and finally they came up with the image. There is a pre-processing involved. So we will look at how to pre-process images, reduce noise, and all these things in our coming sessions, right? But this should just give you an idea that the format of the data differs from scenario to scenario. In some scenarios, you will have data coming in a structured format, and in some cases data like this. And you also have semi-structured data. Semi-structured data is, they are partially organized, but you cannot make them into tables. For example, you have something called as JSON files or XML files. So what happens is, some of the chemistry equipments or the apparatus, the digital apparatus that we use in chemical labs, are connected to some sort of sensors. These sensors will collect the readings, but they will not store it as a tabular structure. They will store it in a JSON format or in an XML file. Okay, or basically they will be storing them as logs. For example, your lab has an instrument. So that lab will have lot of instruments, and when you switch on an instrument, a log will be written. The log will say, at 9 o'clock the machine got started, right? The machine was powered on, and by 9:05 the machine was ready for use, and 9:10 the first entry happened. At 9:15 there was a power fluctuation. At 9:20 the temperature increased beyond the threshold. Like this, it will keep on logging some information. So this log is also an unstructured, sorry, not an unstructured, a semi-structured. There will be a structure, but you cannot put them in a table. Meaning, there will be each line will have a format. Okay, but the point is that you cannot say that all lines will have same number of characters or words. You cannot put them in a rigid table, though they will have some sort of structure. And finally, you have time series data. So time series data is basically, you have you are taking readings, okay, or you are not just readings. Let's say you are seeing how a particular chemical's color changes over time. Let's say you have some chemical, you put it in a beaker or in a small glass or in a small plate, and then you leave it. Over the time, you want to see how the color changes, right? Or maybe you are conducting an experiment and you want to know how the reaction rate changes as you increase the temperature, right? Or the sensor data that comes from various chemical processes. There are so many chemical processes where you cannot manually go and take reading, because those reactions are bound to emit some harmful chemicals, which is not good for our health. So what you will do is, you will start the reaction in a closed chamber, and then there will be sensors which will collect this data and will keep sending you this data, and for every second or every minute you keep getting the data. So this type of data is what we call it as a time series data. A time series data is a data where always one column is the time column. It could be date, or it could be date and time, or it just could be time. So one column will always have time. If you find such a table, then that is basically called as a time series data. Not necessarily, but a time series data should definitely contain the timestamp, or what you call the date and time, or at least date, or at least time. Okay, so that doesn't mean that if there is a table with date and time, it is a time series data. No, it could be it just could be a structured data. But if it has to be a time series data, then one of the column has to be a date and time, or date, or at least time, right? So again, there is also one more time format called epoch timestamp. Okay, I don't know how many of you have heard of that term called epoch timestamp. So in order to have a uniform, time, suppose I am creating a experiment in India, right, and somebody is creating an experiment somewhere else. So our time zones are different. One way is you can always add your whatever time zone you are, you just add it to that universal timestamp. Another way of doing that is by adding something called as epoch timestamp. Epoch timestamp means when the first Linux was booted in 1990, some 1970s, the first time they started a counter which basically is 1, and after that every millisecond that number keeps on increasing. Okay, so if you just go to Google and type epoch time, okay, so it will give you a timestamp. So if you on your screen, if I just go there, so this is the epoch time. This means these many okay, now it supports in nanoseconds. Okay, so these many nanoseconds have passed since that starting of this counter. Okay, so this is called unique epoch, right? So 00 1st January 1970 is 0. After that, every millisecond, microsecond, that counter keeps on increasing. So it's a universal timestamp, and then based on that it can be converted to any such timestamp. So as a data scientist, okay, you should know that there is this such a timestamp where it is not going to be a simple time, it is basically a number. Then this can be converted to a human date format. Once you get the date, you will basically can convert that, but it is going to be a universal way of exchanging. Okay, it is like the dollar, right? You have dollar, you can convert to anything. Similarly, if you have epoch timestamp, you can convert it into whatever time format or date format that you want. So especially when dealing with the what do you call this kind of data, the especially when you are dealing with time series data, you will probably encounter this type of data called epoch timestamp. So always remember that. Now, what is its relevance, the chemistry relevance for that? Most of the lab works generate structured and time series data. Advanced researches often involve unstructured data like spectra or images. AI models need to understand what type of data they are handling to give meaningful insights. Suppose if I give an AI model some data and I ask it to work on that, it needs to know what is the data format. Then only it will be able to generate meaningful outputs. Otherwise, it wouldn't be able to do that. So these are all the various data formats available in data science. Again, there could be some other few more data types that are available, but we will not be looking at that right now. Right now, we will be looking at time series data, structured data, unstructured data like images, text files and stuff like that. and semi-structured data like log files or XML files. Okay. So, this ends the session topic on uh, the basic data formats that are available for data science or AI. Thank you.